So I'm going to show you real quick just an example of some of the one of the multiple regression problems you might see on our math page. There are other examples on our Blackboard about how to do these problems, but those examples involve using Excel. I understand not everyone has Excel, so this video is going to show you how to use a website that does all the same things that Excel does. I think actually in a much easier way. So I recommend pretty much everyone choosing to use the website rather than the Excel method. But again, some of you might be more comfortable using Excel. So it's totally up to you. Okay. So this says a researcher would like to predict the dependent variable y from the two independent variables x1 and x2 for a sample of 12 subjects. Use multiple linear regressions to calculate the coefficient of multiple determination and test statistics to assess the significance of regression model in the partial slopes using a significance level of 0.02. Okay. So hopefully you were able to watch the introductory video for multiple regressions so you can understand when these things are used and how they're used. And when we calculate these regressions, we're going to get an awful lot of variables. So we don't need most of them, but MyOpenMath asks for them. So I'm going to show you where to find them in the data readout. Okay. So if you're not going to use the Excel program, that's fine. The first thing you want to do is go to the internet. You want to go to this website. The address is stats.blue/index.html. Okay. There's a link to it on our Blackboard page under the chapter 12 course materials. I think at the very bottom, it just says blue stats or something like that. Whole bunch of stuff. You'll see a lot of this stuff we've already done. Confidence intervals and all that stuff, hypothesis testing, yada, yada, yada. What we're going to use today is under the regression column, multiple linear regression calculator. Okay. So what I did was I already went to that and I filled in all the data. So notice here that it has x1, x2, and y. But on the website, it's going to list y first, then your x1 and your x2. So you're just going to want to probably copy the same names or variable names over. So since it has x1, x2, and y, I have x1, x2, and y. And then I just inputted all the data into each column. Okay. So remember, our model is going to look similar to this. Y equals beta naught plus beta 1 times x1 plus beta 2 times x2. All right, we have two variables here, x1 and x2. So we're just going to calculate. Now, don't get overwhelmed by how much stuff is given to us. Okay, there's a lot of stuff right out here. We're just going to go through it part by part. And then at the very end, we'll pull out all the stuff we actually are going to use. So once we calculate all this stuff, the first thing it's asking for is the r squared. Okay. So r squared is going to be in this first box, which is the summary of overall fit. This kind of tests the significance of the overall model. Okay. We'll look into the specific parts of the model in just a second. But the first thing it wants is r squared, a residual squared, which is just going to be right here at this top number, 0.738. Now, MyOpenMath requests, I believe, 4 decimal places for all of these. And luckily, the website automatically reads out 4 decimal places. So we should just be able to just copy it right over. So this is going to be 0.738. And then the F value for the overall test, our F value here, the F statistic is 12.6753. 12.6753. And the P value for the overall test is going to be 0.0024. Okay, that's some statistics based on the overall test. Now we're going to be talking about some statistics based on specific parts of the regression model. So it says it wants T1, wants the T statistic related to the first coefficient. Remember, here's our equation written like this. Our first coefficient is going to be B1, okay, the number in front of the x1. So if you go to this upper box, it has all the information we need. T1 is the test statistic. It's associated with B1 or x1. So if we see where this column and row meet, we get a value of 3.6145. And it wants the p-value associated with that statistic, or that coefficient. And here it is, 0.0056. All right, same thing for T2. It wants the test statistic associated with beta 2, or the second coefficient, which is going to be 1.7995. as well as the p-value for the second coefficient, which will be 0.1055. These are really what we're concerned with, the p-values, not so much the t-value. That's when we get into the p-value, the t statistics. So then it says, what's your conclusion for the overall regression model? Okay, also called the ominous test. So remember, what we're doing here is we're finding the overall significance of our model, sometimes called it's an F test. So it uses the F distribution. And this test is to test overall significance. Okay. Is there something significant that our model has calculated or has shown amongst the data? Okay. So when we're doing this F test, we get to set up our null hypothesis. Our null hypothesis when conducting these F tests is always that, is that every coefficient, beta 1, beta 2, however many variables you're comparing, they're all going to be equal to 0. And if they are all equal to 0, that means there's nothing significant about the model. Okay? So we assume no significance. Okay? So then our alternative is going to be at least one of those betas, one of those b's, does not equal 0. We're assuming that they're all 0, which means there's no significance. And the alternative would be, well, maybe one's not 0, so there has to be some sort of significance. Okay? But since we're talking about the overall regression model, we don't care about these individual p-values. We're talking about the overall p-value. So going back to first, the question itself says use significance level of 0.02. So we're comparing our p-value to our alpha of 0.02. So our p-value is less than the alpha. This is our p-value is less than alpha. So we have enough information to be able to reject, or enough evidence to be able to reject the null hypothesis. So we will reject the null hypothesis. So let's write that out. We say there is sufficient evidence to show that at least, so when I write my conclusions out, I would either say, is there significance or is there not significant evidence to show, and then state the alternative. There is significant evidence to show at least one beta is not equal to 0, which means there is significant evidence to show that the overall model is statistically significant. That's a tongue twister right there. Statistically significant because our p-value is less than the alpha. Okay, that's the overall calculation. Now we're talking about, all right, let's look at specific parts. Can we figure out which one of the coefficients is statistically significant? Okay, which of the regression coefficients are statistically different from 0? So now we're going to use those individual p-values. Let's compare each individual p-value to our alpha. So for the p-value for B1, we have 0.0056, which is less than alpha. And for B2, we have 1.10055, which is greater than alpha. So when comparing the individual p-values, we see that this guy is the one that is significant. It's less than alpha, so it shows some significance. So we could say it's not neither. It's the slope for the first variable B1 is the only statistically significant coefficient. Okay. So even though we've pulled a lot of information out of this model, please ignore my dog barking in the background, that we only really need to show significance overall and between individual coefficients.